Hello, and welcome back to another game development stream. Yesterday, I basically started on a new game, which I guess is going to be my first game, because all I've done so far are a bunch of tutorials, but I've already got a pretty good start from yesterday. Yesterday we set up our character for our game called, work in progress right now, but it's going to be called Mega Gecko Ball. So if we look over here in the Unreal Engine, so this is our character. So far, it's just a red and green ball. We set this up, and basically, so we set up a spring arm and a camera on it, so that a camera will follow the ball around. Let me play this real quick. And now we have a ball that rolls around in our game, in our Mega Gecko Ball game. And we were setting up kind of like the maximum speed and stuff like that, the normal control stuff for the character. And we set up a little basic testing area. I've added a few things onto it, just over here. Well, just one thing really. Just a little like a big bowl area and a little extra hallway type or walkway thing here, just so we have a little bit more to play around with. I also last time I was having issues with my high resolution model for the ball. What I was using was a very high subsurface quality for our sphere shape, and that gave us like it was over 8 million vertices on one model. So I lowered that resolution down, and I have 5 different versions here. What am I using right now? I switched to, I think, number 4. Yeah, Subsurf 4. So it's not the highest quality, it's, you know, the third highest quality. But I can actually load it much quicker, and the frame rate isn't as bad. It wasn't horrible with the maximum resolution one, but it's improved with this one and less loading times. So that's much better. So I fixed that basically. I just had them in here because I was doing some testing. I was testing some numbers on them because I was gathering the I guess the frame time. Frame time or time before? I think it's frame time. For the different versions. The basic game without any sphere in it, or any, well, yeah, I was using just the static mesh on there, not a player. It was like 8.8 milliseconds. We tossed in the really high resolution one, it goes to 14.8 milliseconds. So that was like a 6 millisecond increase for just one sphere, which is that's almost twice the normal. When I go down from the highest down to the Subsurf 5 right here, it went down to 11 milliseconds. So it only went up by 2.2 milliseconds from a empty scene, basically, or my empty test area. I went down all the way to Subsurface 1, like the lowest quality subsurface model, and it was like 10.95 milliseconds. So not much different from number 5, the second highest quality. So between these 5, there wasn't too many differences between processing performance. Just when we go to the original high resolution one, you can see on the tooltip it says 4 million or over 4 million triangles, whereas Subsurf 1 has just under 4,000. So much different in terms of the polygons on them, but performance wise, original was really bad, but 1 through 5 are pretty good. So I just went with 4 because it seemed to load the quickest. I was having trouble loading number 5 quickly, but when you put it in the game, it worked pretty well. So that's just tying up some loose ends from the last stream. I think that covers pretty much what I was doing with this subsurfacing stuff. A cool thing I added, I was going kind of crazy last night because I was kind of bored. It was like midnight. I added in some debug spawn points. So that's what this is right here. I have some debug spawns over here, test spawn 1 and test spawn 2, which is all the way over here by the bowl. So these little, they're called target points. Basically, they just set a location in the world space on your scene. And if we open up blueprints and go to the open level blueprint, we'll open the editor for that blueprint. Bring that over here. What's going on over here? Okay. Excuse me. I didn't want to do this on stream because I wasn't sure if it was even going to work, but I ended up getting it to work. So let me just do a quick rundown of what this is doing, just so everyone is in the loop. I have just these events for keyboard press 1 and number 2. And once we press 1 or 2, we're actually going to set a variable called event key. That's a key structure over here. That's a private variable in this blueprint. And we're actually going to use it down here. And we're going to look through a mapping of keys to spawn points. So let me open up this debug spawn map. So a map is going to basically pair a key variable, which comes out of this key event. And I set it up to map it to, or pair it to the target point, which is it's not, I don't think it's considered an actor, but you know, it's this object, this target point. So this pairing basically means that when I add in an entry for this map, I can pair certain keys to certain target points. So I paired keyboard 1 with test spawn 1 and keyboard 2 with test spawn 2. So I have those 2 entries in here, and they basically create a list of our spawn points. So after a keyboard is pressed, we'll grab that key structure and we'll set it to this local variable. And then we're going to find, at least try to find that key in the mapping so we can see what its pair is, the value. So that's what that is. We're basically searching with this event key in this. So once we do find it, so this returns true if we have found an item in that list. So let's say if it was 2, we check the spawn map, we go to 2, hey, it has a mapping to test spawn 2, so we'll return true in here. So this branch will return true, and then it'll execute set actor location, and we're gonna grab that value, that's target or test spawn point 2, and we're gonna get the location of that spawn point or the target point, and then that's where we're gonna set our new location for the target right here, the set actor location target, which is my player in the level. This is a reference to an actor. This is something special for the level blueprint. Let me show you how to do that. What you basically need to do, at least the easiest way to do it, I think, is to let's say I wanted to add a reference to this box over here. It's too close. So you know, this is like the left box or something. I call it cube. But now I have this selected in the editor. If I go back to the test map level blueprint, I can basically right click and right click. Okay, Oh, there we go. And at the top here, we can create a reference to object name, cube in this case. So now we have a reference to that actor in our scene, or the object. So I was doing that for test 1 and 2, but instead of doing it, I could have just done it where I map, or when I press 1, I pull this, you know, into here, and but basically it was just a bunch of the same nodes repeated, so I don't even need this anymore. Since we set up our mapping, we don't need that reference anymore. The reference is in here instead. See, it grabs a reference from the scene. So once we get our spawn point location, we can set the location of our player. And then we also set the velocity and angular velocity. So we basically freeze in place at that target location instead of carrying momentum and rotational momentum. So that's what we do here. This is just converting from the Gecko Ball blueprint to specifically the root ball, which is the static mesh of the Gecko Ball, because physics is only applied to the static mesh. It's not applied to that whole actor. So that's what that is. But yeah, we just set it to 0 and 0, and that's basically how we can spawn at certain points in the level. So let me show that off. So, you know, let's say I'm rolling around, and let's say I fall off the test map. I'm like, well, now to restart my thing again. But if I just press 1, spawn right there. And now we can also spawn to our second spot. If I just press 2, now we're in the bowl area. And I can press 1 again, we're right here. So I can just switch between little hotspots. That'll make it easier for debugging and testing different physics or whatever, or mechanics. That's all that is. Don't know what that's doing here. Just gonna remove that folder. Just to show off something really quick, in case some of you that don't know, the way I created this little bowl is I used the geometry in this editor. Excuse me. I used the geometry, and to do that, I just you know, made a box. Let's say I put it out here. I scaled it, something like that. Well, usually you don't want to scale. I think with geometry, you usually just want to do the brush settings. So let's say, you know, did 1,000, 1,000, and 1,000. So there's a new cube. Let's just put that down a little bit. So it's a little smaller, but let's look at my point across. Now we want to make a sphere inside of that cube, basically. And if you try to do that, you just get a sphere on top of a cube. You could try to like put it in, but it's just a sphere on top of a cube. So what you can do is you can change the brush type from additive to subtractive, and that'll actually subtract from the colliding mesh, basically. I guess, or the clipping mesh. I don't know a good way to say it. Let me just turn the tessellation up here. That'll make the sphere a higher resolution. So now if we scale the radius up, now you can see that more area was taken out of the bowl. You can continue to go further. If we select the sphere brush again, turn the radius up, maybe to like slagging. There we go. So you can see it took away more. So that's how you can kind of create a little bit more complex geometry in the editor. That's just how I did that little thing. And if you do want to save it as a separate set of static mesh instead of geometry blocks, you can actually like select multiple things, I think. I don't know how to select the sphere brush. Maybe this, yeah. Control click. What am I doing? There we go. So I selected both the sphere and the box. I could just go down to the geometry settings, brush settings, and there's a create static mesh right here. I wasn't having good luck with this because like static mesh. What is it? S. I think we just go with S. I don't know what our nomenclature for static meshes are. We'll just go SM. How about that? Bowl 1. Thing is, it doesn't retain the collision of the geometry. So while you've been able to save it, basically. See, I was doing that right here. Oh, that's really close to the camera. So now I have the same shape, but you know, let's say I were to put it over here, because it's a static mesh. It doesn't have collision on it normally. You have to like tell it collision, but the collision mesh isn't set up on this automatically for some reason. I feel like it should, but it's not. So let's say, you know, it's around there, and we play with this. We try to go into the bowl, and we actually just fall through right there. So the collision isn't set up for that by default. Which is a pain in the butt. You could try to edit this somewhere right up here. Edit. So now we're in the static mesh editor. And if you try to view the collision for this, there's nothing. There's no green outlines anywhere on this. So definitely no static mesh is set up. So let's, did I say collision mesh? I meant collision mesh. So let's try to add a collision mesh. We could try to add a sphere, but it's not a sphere. It's like a box with a sphere minused out. So, I mean, we could try to add a box, and you know, it snaps to the edges just fine. But still, that's not what we want, because it's a box, you know, it's missing that cutout. So, you know, that's not really going to do anything for us. So let's delete that. We could try to do an auto-convex, what is it called? Yeah, auto-convex collision, which will try to automatically do this. You know, let's try to set it to like the maximum. So it's going to take like 20 seconds, 30 seconds to do this. Basically, it's trying to find all the surfaces while trying to stay a, I don't know, like an efficient mesh, you know, not too complex. And it did something here. Let me show the, it doesn't really show well. Oops. Wait, in here, yeah, player collision. So we can see what the collision with the player would look like. And as you can see, it's not really the same shape that it actually is. It tried its best, you know, it came with like a box, had a cutout sphere in it, but it's not a smooth sphere at all. It's jagged and it's not in the general shape of it. So let's put it back on. So that didn't work, even though we were on the max accuracy and max hull verts. So that's just not going to cut it. And it makes like individual ones. It's just like a pain in the butt. So we can just remove collision from there. Another way to do this is with the KDOP simplify collision. And what I mean by KDOP is, let's see if I can remember this. The K is just a variable, you know, like the number of whatever. And DOP stands for, I forget, like something of planes or something like that. So basically, it's gonna make a number of planes and put them as close to the mesh as possible. And I think the D stands for degrees or something like that, because it like is, you can see from the tooltip it says axis aligned box collision mesh. So it like tries to rotate the planes and stuff like that to try to, you know, meld against the shape of the object, except it doesn't really work well. So let's just do like 18 dop simplified, and that's it. It just made a box. That's all it is. So that's not gonna help us. What if we did, you know, like 16 dop? Same thing. I thought it was gonna do something different, but it didn't even do that. Let's check. What am I doing? Lit. Let's try the Z-axis aligned edges. That didn't do anything. That's another box. That's another box. X. That's just another box. So we just created some boxes, which we could have just done with that. So it just didn't work in this case. I think because it's like a convex shape in the cutout, that it just doesn't find it. Because it finds like the top plane, I'm assuming, and therefore it doesn't want to go down any further and, you know, like kind of cut out that. So that just won't work. That's why the convex collision sort of works, because it can do the convex contours, you know, the cutting in shapes and stuff like that. But, you know, if we were to try to do like something like this, make a capsule, you know, we could try to, you know, scale it or something. But since you can't really make convex collisions with this, it's just not going to work out. So I ended up just saying, screw the static mesh, I'm going to use the geometry. So this is just the geometry part still with the wait, what did I do? What happened here? Oh, did I make another one? I don't know what I've done. There's so many collision things. Okay. So yeah, when I said create static mesh, it actually replaced the geometry with that static mesh. So now there are two sets of geometry brushes. So that was something else I've done since yesterday's stream. I think that's it for the level. Now I did do a little bit more fiddling with the character off stream, so let's remove these two static meshes. I don't need these. So let's edit the gecko ball. So there's a lot of stuff here now. Kind of went nuts last night. I was kind of geeking out about it too. I'll explain why I was geeking out about it. So I don't remember exactly if I showed this off. I'm pretty sure this was in yesterday's stream. So in the event begin play, we set a max angular velocity. I don't know if this was in the stream. So that we don't rotate too fast. So I set this as a default to, what is that? Is that 5? No, 4 rotations per second, or 4 times 360. So yeah, full 4 revolutions per second. And I don't know if that's like the magnitude of the angular velocity, or if that's for each component. I'm not sure what that does. But I've added that on so that just when we spawn the character, we instantly set the max angular velocity. There was not a way to do that for the linear velocity, so yesterday we created some logic with the event tick, so that every tick, for now we're gonna print out a debug string so we can view the speed on the player. I'll show that off right now. So in the top left corner, right over here, you'll see that in green, that is the speed of our character. So as we roll around, we'll pick up speed, we'll go faster. As we slow down, you know, the number goes down. And we set a max to, 3,000. So this number will not go any higher than 3,000, like that. And we did that by first seeing if the magnitude of the velocity was greater than our max velocity. So if it was, then we're just going to set the physics linear velocity down to, if we trace it back, the maximum velocity, 3,000, times by the normalized vector of the velocity, so that we maintain the scale of our X, Y, and Z velocities, because they're different components. They're individual components, I should say. So we need to respect those components. So, you know, if we're moving in, you know, X and Y, we need to make sure that the sum of those two velocities, not the sum, well, like the math, you know, the physics math, we make sure that our total speed is not greater than 3,000, and we'll kind of clamp down to 3,000 if we're above it. That's all that normalize vector does. Now there's a lot of extra stuff below all that stuff. So that normalizing and max velocity stuff, that was the last stream. But last night after the stream, I basically decided that I wanted to make sure that when our character slows down sufficiently enough that the ball actually slows down to a halt. Because what I was noticing is that even though we like slowed it down and it was moving pretty slowly, we still were moving like just inches at a time, and like it was hard to stop at a specific point. So if we go back to our ball right here, let me just change the spring arm, because I rotated the spring arm around. This is the default position. So let's say I'm just excuse me. Let's say I'm just moving this way and I want to slow down, so I kind of go to the left a little bit, slow down, and now I'm waiting for the ball to stop, and it just won't stop. But now it has. So basically what I've done is, once I hit like a certain speed, I decide to force the ball to slow down to 0. So if we notice, I set it to 45, I think. So once we hit like 45, you'll see the number just goes down to 0 very quickly. And right there. So it basically scales down, not like linearly. I was doing some math to do this wacky control loop stuff, which I'll explain. But now we're basically at near 0 velocity. So if the player wants to stop and, you know, take a think, they won't have to worry about like rolling off the edge or something like that. They can just hands off the keyboard, you know, look around, mouse around, you know, try to think, you know, okay, well, you know, if I roll that way, you know, will my timing be good or anything like that, you know. So the way that I did that, let's stop this, is the first thing to do is to decide a certain threshold that we need to pass for velocity. Because basically, if you think about it, the player spawns at 0 velocity. And if we say that we want to automatically stop at 40 velocity, or 40 centimeters per second right down here, then we would basically never move, because if you're at 0 velocity to start and you start moving forward, if you're always clamping down to 0 velocity, if you're under 40, then you're always going to be at 0. if you think about it that way. So we need to make sure that we allow the player to get past 40 so that we can say, okay, so now we've passed a certain threshold. Now the next time we get close to 0, which is less than 40, then we're going to stop the player. So I set that threshold at above 40 because I don't want any like noise or anything like that from the physics calculation to accidentally go less than 40 for like 1 frame, and then all of a sudden you stop the character before they're, while they're trying to accelerate. So let's think as a player, they're playing the game. So they spawn, and they start at 0 velocity. They start accelerating up. Eventually, very quickly, they'll pass 50 centimeters per second. So we'll check the magnitude, and we'll see that the speed is greater than 50. Therefore, we're going to go into here, which is basically saying that we are now ready to stop next time the player gets or slows down. But for now, they're accelerating up. They're moving normally. So we don't want to stop them while they're, moving. So we'll check to see if, excuse me. Let me take a drink of water. There's a lot of talking to cover what I did off stream. So we want to check to see when is a good time to stop. So I set it at 40. I might expose this later on so that we can change it in the editor. But for now, I was just messing around, so I set it at 40. I decided that was a good place to stop. So once the player slows down, oh wait, let me just clarify. Okay, so we're accelerating, and once we pass 50 centimeters per second, player's up to speed basically. Then we can set this Boolean variable called ready to stop. It defaults to false, meaning that we don't want to stop while we're at 0. Got some gas. Ugh. I was eating some ribs. Anyways, now we set ready to stop, meaning that next time we get below 40 centimeters per second, then we'll stop, because we have to check that flag. So that's what that flag right down here is. So if we do get lower than 40 centimeters per second and we are ready to stop, that means we have been up to speed already, then we can start to do our slowdown. Otherwise, if we're greater than 50, we're just going to set the ready to stop monitor little Boolean thing, and then we're going to do our maximum velocity stuff right here. Because we're up to speed, we want to make sure that we don't go over the max speed. So that's what all that is. I covered that already. Now the other branch here, when we're false, meaning that when we're not up to speed, we're basically below 50 centimeters per second. Then we'll check to see if we're at our stopping point, which is 40 centimeters per second or lower. And we have been up to speed. If that's true, then we'll try to slow the character down. Otherwise, do the max velocity stuff anyways. But since you're in between 40 and 50, or we haven't been up to speed, it's probably not going to clamp down your maximum velocity, but I just decided to do that anyways. So for the slowing down stuff, this is a lot. Let me explain the first explain the basic concepts behind what I've done here. What I've done is I made a feedback control loop for our velocity. It's very messy right now. I didn't find a really good way to organize it. Anyways, so the feedback control loop. What a feedback control loop does is it'll take an input, which is our velocity, our character's velocity. it will modify that input, and it will output a new number, which in this case is going to be a velocity that's slightly lower than the input velocity or the original velocity. So that means each time that we loop through this calculation where we go lower, slightly lower than our previous our current velocity. Okay, let me think about this. So I should just draw this out somehow, right? Do we have like paint? We have paint. I don't want to use that drawing app I used yesterday because that was slow and buggy. So we have our, I don't know if I could just draw an arrow. Just, what is this arrow? There we go. So we have a input velocity. We'll just call this, in. Hold on, learning controls, in. Okay, I don't know how this works. In velocity. Let me just click off of it. There we go. I spelled it wrong. God damn it. In velocity. That's our in velocity. And for our control loop, we're going to take that velocity and we're basically going to reduce it by some amount. And we're going to call that amount delta V. So let's take this. We'll say V, I'm going to say minus delta V. And that's going to equal our NV, our new velocity in this case. So that's going to be like the math that we do. So once we take that number, we can output it as like the new velocity. Spell it right this time. But since it's a loop, we're basically going to take that new velocity, we're going to pipe it back into the loop. Oh, that's not the right arrow. And say that our new velocity is now our new velocity is our input velocity. So each time we go through this loop, we're slowly decreasing our velocity by a certain delta. Now the importance of feedback control loops, this is called a feedback loop, by the way, where you take an input and you have an output and you loop it through this this little, I guess, diagram, this little concept of repeating something over and over based on the resultant data. It's not just like math and stuff like that. It's used in like psychology and sociology, I guess. Where people like behave based on the responses they get in life. And, that's how, I guess, like riots form. You see like a couple of people doing crazy things. Then those people that see those things might join in, and then you'll see more people doing the crazy things, so more people join in, and then it just keeps going and going and going, and you create a positive feedback loop, which is just a loop that kind of goes nuts. It's like this is a positive feedback loop, where it's like you start going slowly, and then all of a sudden you ramp up, and you kind of go without any end in sight. So you probably have heard of like a positive feedback loop. It's kind of like this basically, and positive feedback loop means instead of like subtracting or going towards a certain goal, which our goal in this case is 0 velocity, it's just kind of going off into infinity. I should say less. I just thought of that right now. Anyways, let's get back to our example. So we have the basic structure of a feedback loop right here. I had to decide basically what this delta V is going to be. So I wanted to basically just like draw a graph of what I wanted my velocity over time to look like. So I drew this on paper. Let me just represent this in a little drawing over here. So this is a axis. Got two axes here. This one is velocity. That's basically our y-axis. Over here, we have time. So we can basically draw what we want our velocity over time to look like. And normally when we're rolling, we are slowing down because we set a physics property called linear damping, meaning that our linear velocity is going to be damped over time, meaning it's going to go downwards. So basically, during normal play, when we're slowing down, our velocity over time is going to look like this, where it's just like kind of a straight going downwards, kind of slowly going downwards. But I want to make that go a little bit faster, kind of like that. But doing a sharp drop off like that, actually, I first tried doing a sharp drop off like this, just going straight down. So this right here, that's a bad line. Let's try like this. This drop off point, this is the velocity that I want to slow down at, which is right now 40. That's the velocity that I want to slow down at. So I decided at 40, just go down to 0. And going from 40 to a dead stop looked really bad. So I did not want to do that. This is a stupid eraser. All right. So instead, I want to do a kind of drop off like this. But it's very easy to do a linear drop off like that. And I could have done something like that, but I was a little nuts yesterday. So I wanted to do a little drop off that looked more like this. It looks like that, kind of. It was more like this. So the drop off was still smooth, but it's more of a sudden drop off like this. So it kind of came to rest a little bit more naturally. But this is kind of hard to do without doing a complicated feedback loop like this. So I basically had to decide, well, how do I get from velocity to this graph? Because that's all I have. Well, actually, we have more data that we can use. We have the delta seconds, our time between ticks. So now we have a time unit, our time scale, I guess, in the tick event. So we have velocity we can control, and we have time. And I just need to figure out, how do I get a change in velocity over time? Because, you know, we have this, we can get this, we just don't have this dV. So I don't know what that line is doing over there. Let me just try that again. So it was looking like that. So I had to just decide, well, how do I get a line like that out of a dV value? I was thinking, basically it had to be done in ticks, right? So we have like maybe a tick right here where we see that we're lower than 40. And then we have another tick. Let me zoom in here. That's wrong area. I guess we're just going to have to deal with it. This really sucks. Okay. And then, like, you know, stop it. Then we have another tick right here. You know, just see that, you know, we're going down a little bit in our velocity. Next tick, you know, it'll look like this, where we're going a little bit further down. Next tick, we go down even more than before. The next tick, okay, this is starting to, you know, go down a lot more. Then we get to like this tick, and it's like, okay, you know, we're almost halfway down to 0 already. Next tick, you know, it's like we're pretty much at 0 now. And then another tick, you know, like this. So I was kind of thinking like that. If I separate out this line into chunks of time, you can see that the change in velocity, or the delta V, is represented kind of exponentially going downwards, right? So I made a new graph called dv over time. Let's just increase the size a little bit. Sorry if this is a little bit stale, but this is part of game development, doing math. So this is the new graph I made. dv, let's press escape. dv, delta v, or change in velocity with respect to time. So I'm trying to think, okay, how do I get that graph over to the upper right? Since we're starting small, it maybe looks kind of like this, but then it started to raise up exponentially, then it was a lot, and then a lot, and then like the change in velocity was a lot like that. So at first I thought, well, that looks like a parabolic function. You know, y is equal to x squared, right? You know, that would look like this a little bit. There's your arrows. So it looks a lot like that. So we could say, well, dv is equal to time squared, right? I think that's what I ended up going with. Just this graph, basically. Yeah. Let me double check. Yeah, our time squared. So that's basically the control loop curve that I wanted. So to basically code this, or in blueprint terms, code, we have to recognize that, you know, each tick we have a certain time allowed. So we need to accumulate that time so we can see at which point on this curve we are at. So to do that, the first variable I use is RTST_sum right here. So it's a summation of something or another. It's not gonna summation of dt while calculating, or the delta time, or the change in time, while calculating ready to stop control loop. So it's basically gonna add on from this node. It's going to add the sum with the current sum with the change in time, the delta seconds. So it's going to start at 0, and once it wants to start summing this together, it's going to first add on the delta time for the first tick, and now it's going to have that in there in the RTST sum, and then the next tick is going to add that to the previous sum. So it's going to continually increment this with the number of seconds between ticks, and it's only going to do this if and only if we are ready to stop and we're less than 40. So once we know we want to slow down, then we're gonna start doing this math right here. So basically, if you think of our origin point down here, our 0, 0. 0 time is the time that we want to start slowing down. That's time 0. So that way, when we know we want to stop, dv is basically going to be 0, right? Well, I calculate the first tick, I guess. So it's going to be the time since the last tick. So it's going to be a little bit more, you know, it's going to be like right here. Oh, that's a horrible line. You get the idea, you know, right? That's like going to be the first tick instance. So it's going to be a little bit of a dv, but not much. It's going to be like just above 0. So that's basically accumulating our time. Now the other thing we want to do is, well, we need to set the velocity. We're basically at this point starting our control loop math. So we need to calculate the new velocity by doing the current velocity minus our change in velocity. So we get the current velocity right here. And I do a couple things right here, but the first thing we want to do is get the magnitude of the velocity. And we want to subtract dV from it. So we take the magnitude minus the t sum. My brain just like stopped there for a second. Velocity magnitude minus t sum squared. So RTS t sum, we have the power node, and we have the exponent of 2. So t sum to the power of 2. We do that calculation in this node, and then we subtract that from our vector length, our magnitude velocity. So now we have our new velocity that we want to go to. So now we apply it to the normalized vector, just like we were doing for our maximum velocity. We're basically scaling down our vector so that x, y, and z components are still at the right ratios to each other, but the total velocity, the total speed, is going to be reduced. So now, basically, we have our new velocity right at this node. So then we can just slap it into our linear velocity. You can see I actually broke it out here. So instead of going from get linear velocity to set linear velocity, I actually did the angular velocity too. Same math down here. It's the same exact stuff. Actually, I probably should have put this, basically all this math. I could have put this into a function, basically. These functions over here, you can put, I mean, they're basically just new event graphs. And you could do the same thing over here. You know, get actor, you know, whatever, you know, get actor location, whatever. And you'll have inputs and outputs to these functions. Just to, you know, do this quickly. And you can end up with a node that looks like this, but it's going to be your custom function. No, delete the function. There we go. So I could have slapped all of this into a function, and I probably should have. It would have looked a bit better. But I was just, you know, testing this out, and I wasn't sure if the control loop would work. But again, same math. T sum squared, that's our dV. Subtract that from the angular velocity speed, or angular speed, I should say. I say speed and velocity. Velocity in physics terms is usually thought of as these separate components of x, y, and z. But the magnitude of velocity is considered your speed. So speed is not thought of in you know, components x, y, and z in 3D space. So speed just is total velocity. Think of it that way. So that's what we're doing here. We're getting the speed right here. And in this case, it's just the angular speed. We do the same stuff here, and we set that to the set physics angular velocity in degrees. Yeah, I just want to make sure that we got the velocity in degrees as well. I don't want to like mix up radians and degrees. So that's basically the control loop. You know, we get the current velocity here, we do the math right here, and then we get the output right here, and we close this control loop. Basically, we loop back around. We do that by basically setting the velocity of our gecko ball, so that the next time we get the velocity of our gecko ball, it'll be basically the stuff that we set previously. So that way, in that way, it's a closed control loop. For those that know what the difference between an open and closed control loop is. So after all that is done, all that mess is done, we check to see if we have sufficiently stopped. So just to check this condition, just wondering, oh, I can select all input nodes. So we trace that line all the way back to this node. We basically check to see if our speed is less than 1. So I decide, you know, if we're less than 1, we're pretty much stopped. So I'm going to stop the control loop. So I set ready to stop to false. So now that first threshold velocity of 50 can now trigger this again, basically. I call that the auto stop monitor because it monitors if we can automatically stop. Then we have the reset DT accumulator. That's our RTST sum. So that graph down here, you know, we're doing ticks like this, you know, we're getting DV, and then once like we get to here and we decide that we hit 0 velocity, our goal, then we're just going to stop this, and you know, we're going to resume back to the start of the DV curve. Just resetting everything for the next time we need to stop. Oh my god, I've been talking for an hour on stuff I just did last night. I probably should have just streamed it. It might have been quicker that way. No, it took me like 3 hours last night. I was having fun though. I was really geeking out about that stuff. Just math, you know. It's so stupid. Stupid math. It's fun sometimes. I don't know if I sound like a crazy person or not. And yeah, anyways, this looks kind of messy. And for some reason, if you notice, the branch nodes kind of jump around. Like it overlaps this node, all of a sudden it jumps and stuff like that. It's a bit weird. It's a bit frustrating when you're trying to make it look nice and all of a sudden it's like colliding and stuff like that. OCD. OCD. But let's do some new stuff. I don't know what I have to compile. I hope I didn't break anything. Well, I made a function and deleted it. Yeah. Anyways, I made ready to stop and RTST sum private variables. So those can't be edited by other things, and they can't be edited by children of gecko balls. Because they're basically internal variables. They should not be exposed. So I think that wraps up all I've done. Can you believe that? All that explanation, all that drawing. I don't need that anymore, but all of this jumble of nodes just so I can see my character come to a neat and soft stop at 40 centimeters per second. Like that. So there you saw like the exponential drop off. Or is it called like quadratic? I forget the names. Get them mixed up. I love it. I don't know why, but I just love that. I could have just set that velocity to 0 at 40 and just had the jarring stop, but we're not here to make crappy games, right? Anyways, so what are we going to do today? Today, we're going to work on camera controls. That's what the focus of this stream is after an hour of talking. So let's stop this. So right now, we cannot control our camera at all. It is fixed at this angle. Let me highlight this. Let's move it out of the way of that light stuff. So you see the screen arm, that red component right there. That is fixed at that angle. Both the pitch and the yaw is fixed. Obviously the roll, which would basically like rotate the camera around a circular axis. Axis. I don't know why that sounded weird. Let me show you what that would look like. This is a roll. You can see in the bottom right, the camera is just, we don't want that kind of action. That's not going to be controlled by anything. What we do want to be able to control, the player controlled, is the pitch. So you can change where they're looking. Right now we just have it set to negative 30 degrees. Like that. So we're looking down onto the ball. That's fine. And the second angle we want to change is the yaw value, the z-axis. So we change this. That'll basically rotate or orbit the camera around our character. So that seems like a pretty useful camera control. More important than the pitch. So another thing to note, I guess, while we go into this, the yaw, it can do the full rotation, 0 to 360. That seems like a good idea. What we don't want to do is for the pitch, we probably don't want them to be able to look up too high. Looking up this high, I don't think we want to have the character or the player be able to look up that closely, because it obviously obstructs the camera view. So maybe, you know, we set it to a limit of like maybe negative, or I guess in this case positive 5. So they can kind of look upwards, but they can't look up too much and obstruct their view. And again, with the other side of things, we don't want to go over the head of the character. We want to limit it at the very top, basically, so that if we look at it from the side view, we don't want to go this way and turn our camera view upside down. We don't want that. So we want to limit the pitch to like that value. So, you know, like this will be the maximum. This will be the minimum. And I think that'll allow the players some good controls for problem solving and the platforming and stuff like that. And I guess for any mini games and stuff, you know, we'll decide that in the future for mini games and other activities. So let's set it back to the default 30, negative 30. So we got to think, in what ways should we allow the player to control the camera? Normally, it's done with either mouse movements, as seen like, you know, third-person shooters, or I guess first-person shooters too. Mouse movement usually controls camera. We can do that, and we can also do like on a gamepad, the right thumbstick is usually used for controls. Obviously, if you haven't played games, you might not want to make or do game development. You might want to play some games first. That is not meant to insult anybody. Just as advice in case you have not played any games. I don't know why you're here if you haven't played any games. Anyways, so to do that, we've done this before. We need to set up a input mapping for our controls. So we go down the engine list, click on input, and the bindings right here. We want to add new axis mappings. So now we just have move forward and move right. These are pretty obvious. So let's add camera up. No, let's call it camera pitch. So we relate it to the actual names of the rotations that they give in Unreal Engine. What I do? I do not want to expand this. So we can use the mouse, and for the mouse we have X and Y. I should not click on that. X and Y, that's for movement. Then we have the mouse wheel. There's just an axis mouse wheel, so it'll return like from a certain value to a maximum value or whatever. Well, I guess from a negative value to a maximum value of the opposite. Whatever, you know, so it's the games or the gamepad stuff. Same behavior as this, where you set a maximum and it goes from -1 to 1 in this case. So with the mouse wheel, we have left, right, middle, thumb, mouse button, thumb, mouse button 2. I'm not sure how to get more mouse buttons in here. I'm not sure we'll need it for this, but I'm not sure. I'm just not sure. And I don't know how to do dynamic keyboard mapping or control mapping yet, which I guess by dynamic I mean in-game key bindings. You can see that in many games, and also in here. Not in here. Let's just go to the editor preferences. There's keyboard shortcuts. These keybinds are dynamically set. We can type new bindings. We can even set 2 two bindings. So if I want to save, I could either do Control S, but if I wanted to do like F4 or something like that, then there we can, you know, have two options for doing a certain input. So that I don't know how to do yet in a game, just like we can do this in the editor. I'll probably do some research off stream for that. Anyways, what else do we have for mouse? Oh, weird. That's all for mouse. So camera pitch. That's looking up and down. That's going to be the mouse Y. Because I'm assuming mouse Y is just up and down movement on your mouse. I mean, that makes sense to me. Unless the Unreal Editor developers are messed up in the head. And also the gamepad, we want to do the right thumbstick. And there's the axis. I keep getting my axis pronunciation wrong because I think like axes, axis, and axes. I don't. Why am I broken? Why is my brain broken? We're gonna go with the y-axis. I'm assuming that is again up and down movement on the thumbstick. All right, camera pitch, not camera pitch, camera yaw. I'm thinking about the scale. I think moving up. Oh, there's another question altogether. With camera controls, there's usually inverted types too. Huh. So we could also have an option in the game to invert the camera controls so that pressing up on your mouse would aim the camera downwards. Okay, I'm thinking pressing up should result in positive. We'll just stick with positive and we'll see what works. we might just flip it around. We'll just do some experimentation. Mouse X and gamepad right thumbstick X-axis. That is all fine and dandy now. So we have two different options for yaw and pitch. All right, that's good. So let's go into our Gecko Ball. And I have a comment here for input events, so let's slap in camera controls for that. We have camera pitch. 10 lines up. Camera yaw is next. All right, so that's our two input events. So that whenever one of these inputs is triggered, then we can do certain things. So we have the spring arm. We basically want to move the spring arm around, I believe. I think that's the thing that we want to rotate. Just that's what we're doing in the editor, I guess, is rotating. So let's just put a reference to that spring arm in here. And let's see what we can do with it. Rotation. So we can add a delta to the rotation. Let's see what that does. Relative to his parent. I don't know which one it would be. Let's go to local. Because I'm assuming it's going to stay at its default of 0, -30, and 0. So if we're using the local rotation, we'll be based off of that set. So So we have our target. Let's execute that right away. And we'll need to make a rotator. So a rotator is just like a vector that we've been dealing with, except it deals with rotations. It's still the same 3 variables, X, Y, and Z, but they have different meanings now. It's, roll value, pitch value, and yaw value. And that's for the values we're messing around in the editor before to test out mins and maxes. So we'll take this float value and we'll just I guess we'll just make an array or rotator. We want to make a rotator. So now you can see it's going to output that purple lavender color, which means it's a rotator type. And we want to not do roll. This is camera pitch, so we're going to do pitch. So let's break that link to the roll. Only pitch and plug it back in. So that might be decent enough. Target is scene component. I don't know what that means. Is that normal? Yeah. Maybe. Target is primitive component. I'm not sure what this means. Target is scene component. I hope that's okay. And let's just copy this same stuff down here. Expand our comment a little bit. But this is camera yaw. So let's hook it up to yaw and execute the add local rotation. What are the other options in here? Sweep. Not currently supported for rotation. That's fine. And teleport. Doesn't matter if we teleport really. Because we're a sphere, nothing really... Well, it's a spring arm, so we're not really going to collide with anything major. Okay. So that's compiled already. So let's see what that looks like. Okay, we're doing something here. So that's my camera pitch. That looks about right. Camera yaw. It's doing something funny. So I get what the local rotation now does. If we look at our object and we're looking at the spring arm, right now this coordinate is in world space. So the Z is straight up, X is straightforward, and Y is straightforward. Which you can see with the rotations, that's what they are, straight up. Now that's in world space. Now if we go to local space, let's see what that looks like. It doesn't. Okay. I thought it would show that X all of a sudden would be so what I'm assuming is doing, which is not exactly what I thought the this stuff does. I don't know why it's not, but this line goes for the spring arm goes straight towards the ball at this angle. So straightforward in that direction is going to be X. So it's not going to be horizontal anymore. And that means our Z is going to be slightly skewed as well. So it basically made a new rotation. So it added that rotation onto our input rotation. So we don't want to do local. Pitch is fine because, it's just changing what we already have. Hey guys, how's it going? Just noticing in the chat. Hope you're enjoying some hardcore blueprint creation. Because this is where stuff actually gets done quickly. As long as you know what to do. Search for rotation. Let's... what is relative again? Relative to its parent. That sounds better. Because if you think about it, this rotation right here, that is the... let me click on spring arm. This rotation right here, that's the rotation relative to root ball, the parent. So the default of that. I believe it'll edit these values basically when we add the rotation. That sounds about right. Let's hook up this stuff. I'm going to straighten these out so they look nice and neat. And we'll hook these in, compile, and run. Oh, I did not hook this up. Okay. So now this is pitch, and this is yaw. That's much better. So now we orbit instead of doing the weird skewed plane. That seems okay. But I have to drag my mouse around a lot to look around. It's not very sensitive. It's got a low sensitivity. So we're going to actually expose a variable to basically multiply our rotator so that we change faster depending on an exposed sensitivity. Oh, so you wrote a personal speech on game dev. Was there a specific topic to it? What the hell that is game dev is people who shut your ideas down. You're self-scoping to the point of unmotivation. Yeah, it can happen sometimes with any project, not just game dev. I know that sometimes. And of course, bugs. Happens with any computer-based anything. There will be problems even though it looks just fine. So let's apply that sensitivity multiplication right to our axis value. Well, let's do float times float. Hook that into pitch. So we're just going to break that out basically. Do the same down here. And we're just going to... I need to find like a hotkey for this promote a variable stuff. Let's check it right now. Keyboard shortcuts, promote to variable. Oh, there is none. How about V? Will that work? Yeah, let's try that. So if I just press V on that, you have to drag it off and press V. I don't know what I've done. Must be. Crap. It doesn't seem to work. At least not how I imagined it would. What does that say? Graph editor, promote a variable. Promote something to a variable. What is something? That doesn't help. Material editor. Okay. I don't think it's gonna work. Okay, so we're into all those today. My team denied all the art I made. We found 6 bugs at one level. Felt so unmotivated because with all my art I scoped to the point of stress. I mean, it happens. It definitely happens, but you know, you can always think of the alternative. Basically, opposite of motivation, demotivation. You know, you think, okay, what if I wasn't doing game dev or art for, you know, game development, stuff like that. I could be doing art for a marketing firm where, you know, it's kind of emotionless and people don't really care about it that much, maybe. You know, it could be worse. I hate to say, you know, it could always be worse, but it also sometimes maybe takes finding the right team. I've never done game development before, definitely not professionally. I've done embedded engineering. That was my kind of coursework, and I went to that kind of field right out of college, and you know, just working with that team was just very stale and definitely no emotion at all, and that it can just be really annoying some days, to put it kindly. But you know, you got to find things that you're passionate about, and if you can make that your job, that's one hell of a job, I think. Yeah. If you've done something at the end of the day, and maybe you found something new, or you've learned something new at the end of a day, I call that a successful day. So, yeah, it's definitely something to be proud of. And hey, you know, you get them next time, I guess. Game development, you know, sometimes isn't just a one-man team. You know, it can be cooperation. So, give and take. A lot of things to keep in mind, you know, when working in teams anywhere. People are all different, so it does take some compassion, I guess. You know. So let's just. Wait, I could just do this. That's kind of easy. No, I prefer right click, anyways. What are we gonna call this? I'm just gonna rename it here because that works better. This is camera sensitivity. Now, a good option for this would also be to separate this out into like mouse sensitivity and gamepad sensitivity. But for now, just doing a quick and dirty overall camera sensitivity. That sounds great to me. And let's compile this so we can set the default for camera sensitivity. We're going to set this to 1. It's kind of low, but whatever. 1 is fine. Instance editable, sure. So we can edit that in the editor. Tooltip. Sensitivity. I gotta make sure I'm spelling everything correctly, because like once you hit college, it's just like every like phonetics just escapes your mind. I hate it. I've lost all spelling ability. Sensitivity of camera controls. We'll just say like lower is lower. Slider range, a low of 0. A max, I'm not going to set a max. So now if we go into here, let's change it to something other than 1. Let's double the sensitivity. Let's see what that looks like. Wait. No, yeah, I did multiply it. I thought I forgot how to do it, but I've done it. So that's much faster. So those expert gamers out there will jack up their sensitivity so they can move like a 1/4 of an inch and do a 360 no scope in our Super Monkey Ball clone. Okay, I'm being silly. So we got camera controls that are sensitive, and we did not set limits, so we'll need to do that. And the limits go really weird if you turn it sideways. Now we somehow have rolled our camera, even though I don't have a roll input. So we definitely want to limit this. There's nothing we could do to limit it here. All right, how are we gonna do this? Is there set? You can set the rotation just outright. Set absolute rotation. So it looks like, let me search for max. There is no way to set a max rotation. So we're gonna have to, you know what? Let's do it in the tick event. I hate to make the tick event bigger, but it's our main character, so I think it'll be fine. I guess, you know, that might be enough room. I hope to not do anything too crazy with this one. No control loops. No positive feedback loops on this. It's just camera controls. So I wonder if I could just add another tick event. Or can you only have one? You can only have one, I guess. Well, that sucks. So I guess we're just gonna break off from here. I don't know. That's kind of awkward. Whatever. It's gonna look weird. Anyways, we can do the spring arm reference. Get here, and if we just drag off from here, we can get a context-sensitive list of things relating to the spring arm. One of which is rotation. Let's get the rotation. Can we not get the relative rotation? Oh, it's part of the transform. Okay. I guess that makes it quicker than going through a function. So that'll be the rotation relative to the planet, or to the parent, not the planet. And we want to clamp the values, basically. So let's break this vector, or the rotator, out. I don't know what the two different methods are for breaking a rotator. We don't want to do anything with the roll. We're just going to assume that's always 0. And you know what? Let's wait to clamp these. That's right. Clamp. So let's go into here and let's experiment with this. Let's say -60 degrees. That's that way. 0 degrees. 15 degrees. I think that might be pretty good. 15 degrees. Well, it's that'd be our maximum, I guess, because it's positive, and then we go, as we go lower, we go up. Our camera goes up higher, but we look down. So if we go into like -30, that's our default, and our minimum is going to be like -80. So our min angle, I should expose these, I think. Man, I want to like organize these. Oh my gosh. All right, let's promote to variable. So this is min pitch, min cam pitch. It's gonna be a float, editable, minimum, camera pitch angle in degrees. No limits. Default is going to be at -80. So let's make a minimum camera pitch. They have a max. Cam pitch I'm just gonna go into here, copy the tooltip, go into max, paste the tooltip, and we'll change minimum to maximum. We'll make this editable. No limits on the slider or the value. Default is going to be 15.0, not 155. 15.0. So that's for Y. So let's drag that up, I guess. Same for here. Clamp. Let's move these above, I guess. No. Let's do that. Clamp angle. I like clamp angle better. So we'll do the similar thing here. Promote the variable. Put them over here. Min yaw, cam yaw, editable. We'll paste that same value, change pitch to yaw, so it reads min cam yaw. Hold on. Minimum camera yaw angle in degrees. That sounds like a good description, and that's all good. Default value for the yaw is, we're not going to clamp the yaw. That's right. Never mind. We do not need to clamp the yaw. The yaw can rotate as much as it wants. As much as it wants. There we go. In that case, let's move these back down. I like these down here. So let's make a rotator. That goes into the pitch. Roll goes into roll. Actually, let's force it to every tick, set your roll to 0 so we don't accidentally start rolling the camera at all. And then once we have that, can set rotation, relative rotation of the spring arm. Let's straighten that. Put that right there. And this is what I'm gonna just really hate, is how do I hook up this setter without looking horrible right here. Oh, I hate it. Oh, I hate it. It's gonna look bad. This is what it's gonna look like. That looks horrible. And this is gonna be worse. That's just what I need to do. Since I can't have multiple events firing off at the same time. And that doesn't sound right. I feel like in today's world, you could have multiple events fire off for a single interrupt event thing. But no, we have to use one event node and have everything based off of that. I don't know how we're going to get it to work, honestly. Like, otherwise, I could put it after all of this and basically hook up every currently empty node to a single input of this. I could do that, but then it's going to look even worse, I think, because then you have like this line going this way, this line going over here, then this one going over here again. That would look bad too. And now, like, Blueprints is, like, I could basically move all this down. Like, let's see what that would look like. This is gonna look just like, it's gonna look annoying. That's a good way to put it. So we're taking everything. Everything, I think. I think that's everything. And moving it down this way. That's pretty much enough. Now move this stuff up here. And hey, now it looks more linear. So this stuff is going to be moved down here. And this stuff can be moved down. This can be moved up here like that. Can I select all of this and say straighten? No. So let's select all of this again. Zoom in and make sure that we get a straight connection point so it looks neat. Oh no. Okay, that's good. Move this down a little bit. Move this closer. That looks okay. This still doesn't look great. If I wanted to, I could cut this out and basically put it after this. I guess let's do that. So we're going to break this link. And now our output's going to go to this instead. And now this is going to move forward. How do I make this look better? Move this down maybe. Let's move this just down altogether. This moves up a little bit. There we go. Straighten. There we go. How are you guys doing? Are you holding up? So all this stuff is gonna be put over here. I might just change the target a little bit. I don't know. That looks okay. I don't want the comment overlapping the function at all. And therefore now we can move this out a little bit. So that looks better. Now to actually hook this up. So that goes in there now. Now that goes in there. Move this all up. There we go. So now we have a linear flow visually in our graph. This is really boring. I'm sorry. Sorry I have to do this right now. But at least now I am sane. Sort of. Better. Okay, so now we have the linear flow going on. We have event, first execution. All the data for the first execution goes right here. Move that up. There we go. Now let's move this down. Crap. Straighten. Straighten. I don't know why it's all out of whack, but there we go. Wow. Okay, that looks at least better. Yeah, I might like fix that. The one node with 5 lines coming out of it later on. you know, I'll basically just copy that root ball reference and put one here, you know, put one over here. My throat is starting to hurt. I'll need to refill in water in a bit. But before we do that, let's make sure that we have everything ready for clamping the pitch. Let me just put a comment in here. Clamp camera pitch value. So now this is only going to clamp the camera's pitch, so we don't go above the player too much, and we don't go underneath it too much. So that's going to happen every tick. That check will happen every tick. I was thinking of putting in a branch to say, like, if we're over or under the clamped value, but whatever. I don't think, because I'm thinking like of tick performance. If we have too many things going on, if every tick we're setting the rotation, even though we're not really changing it all, because we still have to go through that same process of getting the values and applying the rotation, even though it's the same rotation. It's going to consume some resources. So actually, I've convinced myself to actually put in the branch. Okay. So we got the relative rotation. We have the pitch. So right here, let's leave that right there. I'm going to do greater than, less than. Can we do a greater than, less than? Between? What kind of math can we do? Compare float. I want to see if it's between values. In range. Holy crap. So we're going to hook up our min-max to this. So let's move all the stuff down a little bit. Looks good. And I'm going to break this link. Now what I'm going to do is going to do a branch. And we'll just connect that right there. And we're going to move this down a little bit. So if we're in range, we are not going to set the relative rotation. Inclusive min, inclusive max. Yeah, we're going to include these. So if we are at our max pitch, we're not going to set the camera's pitch. Hey, you're asking what genre am I creating in this game? I'm creating a rolling game, so it's going to be like a rolling platformer puzzle type of game, like Super Monkey Ball games. It's basically a Super Monkey Ball clone. So it's kind of physics based. That's why I'm taking a lot of time to spend on movement for this game. So like I was saying, in the range, we're in range. Include the values so we don't set the range if we're already at that max value. We're gonna pass that through like that. Let's move these down a little bit. Move this over here. And if we're not in range and this in range check results in false, then we will set the relative rotation so that we limit the pitch. This is bothering me now. The fact that these lines are not level And now they are. Let's just move this line closer. Okay. So now that'll save us a little bit of tick performance. Probably barely any, but that's something. So let's set this to our default of -30. Let's play this. Okay, so our camera works fine. Now if I drag my camera down and we start moving the camera up, we're going to be limited at that -80 degrees. Let's double check. Let's just press F8. We check our ball and we check the spring arm. It's at, well, pretty much -80. Good. Okay, let's repossess the camera. Now let's check the positive pitch. Now this is our limit. I can't move my mouse forward anymore. And let's double check. Our maximum should be 15. Yes, 15. Of course, I could change the max. I believe, did I expose that? I did. So I exposed all these values. So if I were to do like 30, repossess, we can move closer now. So I can fiddle with these values if I'm doing the actual level development, stuff like that, and I decide I want my character or the player to be able to look further up this way, then I could change it, or maybe further down. Like if I need to change it to like 85 degrees, I could change it. But the defaults of my defaults of 15 and -80 sound great. So I can remove that yaw. These two variables I don't need, because I don't need to limit the yaw, because that is our left and right camera movement, which is unlimited. We can move in circles just fine. Great. That's that, right? Great. Now we need to actually change our move forward and move right functions, so that if I'm looking to the right now, if I press forward, we're moving to the left now, because that's the x-axis that way. You know, this is the x-axis, but if I turn, it's still moving in the x-axis. It won't change the angle. So let's go to our input events. And now our force is going to have to change. Before we were doing the x and y vector based on purely our move forward and move right axis values, which is WASD for keyboard and the left thumbstick for the gamepad. All right. So we're going to have to do this after the clamping. But before we make the vector. No, wait. Okay. I think I know the basic way to do this. Let me just make sure I know how to do this. So, normally we have the x-axis, which is straight up, and the y-axis is straight to the right. So this is x, this is y. Now, normally moving forward is going to be in this direction, right? And then move right is this direction. So that's our positive values right here, you know. So that's moving right, that's moving forward. Now if I want to move forward, I basically need to rotate this direction based on where the camera is pointing. So if the camera is pointing off this direction, right, that's our camera, then my forward direction needs to be pointing in this direction, right? And that basically means our move right, it's not going to be pointing this way. So basically I just need to rotate that those two axes so that they're in line with the camera rotation. Now thankfully we have a value for this rotation. This is the, if we go to like this, if we go to the Gecko Ball, focus on that. The moving forward is actually based on the yaw value. So if we're to be looking over towards, let's look over to the angled ramp over there. So you can see in the camera, basically forward is toward the ramp, but you can see it's going to be facing that way, obviously, and we have a certain yaw value based on that. So 0 is the positive X direction. Toward the angled ramp is about 300. So if we basically rotate the X and Y values around over towards that way, that should give us the new force vector. All right, so there's going to be a change right here. All right, and this is torque. That'll have to change too. So it'll be basically in between here. So scale out our comment, move this stuff. Straighten that out. Okay. So in here, we need to do some math to rotate our vector. That's not what I wanted. I want to break this link, break this link. So these two are going to use the same vector, but it needs to be a rotated vector. Now, can we rotate? Apply direction vector. Now it's like we want the opposite of this, basically. That sounds about right. Axis, Z-axis. So that's going to be a constant vector. We're going to rotate around the Z-axis. Because if we look, our movement is dealing with X and Y. The only axis we're not dealing with right now is our Z. Right? So if we rotate around the Z, basically, you know, in a circle around there, that sounds about right. That's a constant axis. Angle degrees. We're gonna have to use a spring arm. Let's move that so they're stacked. Get the relative rotation. Got to move this out. Seen any good movies lately? I watched Bram Stoker's Dracula recently. It was okay. It had very striking visuals. Put it that way, I guess. Also, I guess, kind of discovered that I'm not a huge fan of Winona Ryder. I've never really seen her in a lot of movies, and it's kind of a reason I also don't like her in movies, or I guess as an actress. I was looking at the list of the movies she was in. Let's look into that. That seems all right, right? Yeah, I was looking at the list of movies she's been in, and I've like seen none of them. And not just for the fact that Winona Ryder's in them. You know, I never really seen her in any movies. And, you know, didn't really have any opinion of her until Stranger Things. I'm like, oh, that's Winona Ryder, someone who is an actress and has a name for herself. That's the extent of her that I knew at that time. And in Stranger Things, she's okay. You know, she's doing the crazy mother who has a missing son. You know, that's acceptable acting, you know. That's just fine. I just never seen her where her character, I guess, makes a bit more sense as a character. And therefore, I don't know what I'm trying to say. I guess I've never seen her play a normal role. And Bram Stoker's Dracula is a bit more of a normal character role. I guess relatively speaking, with relative to Stranger Things, the only other thing I've seen her in. Rotate around XX. Let's see if that works. So seeing her act as a character that's a bit more dynamic than the Stranger Things actor or character. I just wasn't a big fan of her acting. Hey, it works. We're moving forward now. Let's reset. So I'm moving forward towards the angled ramp or the box. That's fine. Backwards, that works good. Let's check left and right. So pressing left. Okay, now pressing right. Good. You know, both directions. More both directions. That's good. Pressing forward. Pressing right and down now. Forward and left. Changing directions. That looks good. We're starting to get a game out of this, guys. So now I can actually go over here and kind of mess around with this to see how this behaves. Hey, that's not bad. It's good camera controls. Oh, I've hit this ramp because it does not have double-sided textures. But yeah, we can climb up it. And then we're up on this platform. We can roll over to here. Yeah. This is pretty cool. Basically, our player is starting to come to life now. And then rotation. Let's double check the rotation. I'm just going to roll off the edge here. Okay, so if I'm pressing forward, we're rotating that way. If I'm pressing backwards, we slow down. I change direction. That rotates good now. Change direction again. We're rotating forward. That's the right direction. That's good direction. So now the rotation works just fine too. Whew, that works. That's like the immaculate compilation right there. Where you compile your code and there actually aren't any bugs for the first time. Usually doesn't happen that way. More often than not, it does not happen that way. This seems like a good time for a break. So go get a drink, refresh, go to the bathroom, grab a snack, whatever you need to do to let a few minutes go by. All right, so I'll see you in a couple of minutes. And I guess next is, you know, I put in the title of the stream, movement tweaking. I'm not quite sure what else there is to do for movement tweaking. I was thinking maybe changing the I guess the force input curve in a way. Basically what I mean by that is have a higher force applied when our character is not moving, so that you can accelerate quicker, but you start to taper off the force input towards the end of the velocity curve, so that you're applying less velocity at the higher speeds, more velocity when you're slower. So that might create a more responsive feeling in there. I might go with that, or because this actually seems pretty good right now, the controls, I might do the movement tweaking off stream, but on stream I might actually start doing some Blender work, and I think I'm going to start experimenting with creating level blocks. And by level blocks I mean basically blocks of different shapes that we can make our levels out of. So basically I want to try to see if we can create our levels in Lego format, or building block format. So we take one part of a level and we smash it with other parts of a level to create I guess other level blocks, to create a bigger I don't know, well, it's a combination of meshes, not one mesh, but a combination of meshes, so that we create a big giant connected mesh of smaller meshes for the level. I think that's going to be more exciting than movement tweaking. I'll do the movement tweaking off stream. It won't be much. It might just be doing that the changed force curve for more responsive movement. But all right, yeah. So I'm actually going to save all of this, close this out, and start Blender up. All right. So I'll see you in like 3 minutes or so, maybe 2 minutes. It shouldn't be too long. All right, I will be right back. Alright, let's bring up Blender. I am back now. Alright, so last stream I covered a little bit of my player model in Blender last time, but I didn't do any modeling. So this is my first modeling stream. It's gonna be a short one though, because we've already gone 2 hours, so probably just gonna get started on some stuff, and then gonna move off stream and do some of this stuff. Doesn't help that I'm yawning. All right, I hope you guys aren't yawning. I hope this is really exciting and thrilling, and demonstrates how a game can take quite a while to make. I'm starting to appreciate some of that. Okay, so in Blender, you start off with a primitive, this primitive object. Now this happens to be a cube mesh. We could add other primitives like a cone, keep trying to use Unreal controls and I can't. Or maybe we could add a torus. There you go, there's a torus for you. Or we could add like an icosphere. Or let's add a UV sphere. Get a sphere, that's what I base our player out of. And basically you take these primitives, and what you do is you, let's get back to our original cube primitive. You take this primitive, don't do that. You learn how controls work again. Is it, hold on, shift. There we go. Shift, middle click. There we go. Okay, now I'm back in it. Okay. What you do is you go to edit mode, and you can edit the vertices, edges, and faces of your primitive. That's the basic way to do it. So if I wanted to make a ramp, for example, I could just select this vertice with right click. And let's just bring it down all the way. Like that, kind of. Let me select this other vertice, bring it down. And now all of a sudden we have a angled ramp. Pretty simple. Or I could select this vertice. I could like hold shift, select this other vertice, and now you can tell by this transform gizmo that we have selected the edge between the two vertices, and we can move that whole edge all at once. So now we've created like a little wheelchair ramp, you know, where it's a lower angle. Or I could, you know, invert it, for example. Now, that's the basics of what I'm going to basically be doing on here. I might go into a little bit of like doing a little rendering. Let's see how good of a quality we can get. That's our little preview render view. So it takes the lighting into account, which we don't have much lighting right now, but that's basically if you were to render your object, this is what it would look like. But we don't really need to render things because we're putting them into a game, and the game engine will render those static meshes instead of using the Blender renderer. Which a first thing to note is a good thing to know is that there are different renderers. There's a default Blender renderer. There's a cycles renderer, which is like an advanced version of the renderer. And there's also like the Blender game stuff. I don't know what that is. I'm not gonna mess with it. I know how to use the cycles. So I'm just gonna use that. Just be aware, I'm probably gonna be using the hotkeys that I've, you know, have embedded in my brain after like a week of learning tutorials. So if I don't explain things and things are happening, you know, ask questions, I guess you can do that. Otherwise, try not to freak out, I guess. Like, why is my camera rotating like this? Okay, I think we're good now. Our camera was a little askew and rotated and rolled a little bit. Don't know why. Anyways, so we want to make level blocks. So, first thing we want to do is set our units to centimeters, I think. No, let's just set it to meters. So basically, one grid unit should be a meter. If we select on this object, wait, yes, this. Let's go to object mode. Our dimensions are 2 meters by 2 meters by 2 meters. So that's our 2 meter cube. I don't want that. Let's go to 1 meter, 1 meter, 1 meter. So now we have a 1 meter cube. A cute 1 meter cube. Now, can I open, first let's save this as, let's go up to assets, models, and I'm going to make a new folder in here called level blocks. Let's actually, I'm going to specifically, you know what, I'm going to do MGB, which is my acronym for Mega Gecko Ball. I'm going to move this folder into here, maybe. I'm trying to do things. I'm going to, can I delete this folder? I don't think I can. There are very limited controls in this. I'm going to put level blocks in here. So I'll do all this folder management later. I guess like organizing my existing models I have in that way. This is just going to be a flat 1M. 1 meter, should we go with 1 meter? Sure, let's just go with 1 meter for now. So it's going to be a flat block of 1 meter. What I wanted to do was open recent sphere halved. So this is my player model. And I wanted to check the dimensions of this. So let's remove this little image. Focus on that. Open this up. And our dimensions are meters. So it's not quite, but it's almost 2 meters. It's almost 2 meters. Okay. So 1 meter might not be enough for a building block. That's what I'm thinking. This grid. What is this grid? Display grid. 16 lines. So that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's 8 meters. Let's make a default of 4 meters. How about that? Yeah, let's make a building block of 4 meters. Save as flat 4 meters. Okay, so what I want to do is I'm going to do 4 meters by 4 meters. Whoops. I typed in like a plus sign or something. 4 meters. Okay. So now we have a 4 meter by 4 meter rectangular prism, but it's got a height of 1 meter. We could reduce that to like 0.5. Should we make that even smaller? 0.25. A quarter of a meter. I'm trying to think of actual Super Monkey Ball, and I don't know if they have very thick platforms at all in their game. Maybe they do. I don't know. Let's stick with 25 meters. So that's pretty basic. We don't need to add a material or anything like that onto this, because we can do that all in the Unreal editor. I'm gonna turn up my music. I can't hear myself. I can't hear the music over my talking. So that's the basic flat that I want to create. My idea is to basically make like snap points along each meter point, so that if I were to take like another one of these, let's say Shift D along these X, if I were to take another building block in the Unreal editor, I could just snap this the second flat 4 meter to the first flat 4 meter at that like socket point, basically. I think that would work. And I can basically make levels like that. You know, let's do Y. You know, I snap one right there. So I could use like the flats to do a basic outline that I could put like corners, and I could put ramps, and I use these building blocks, kind of like a level editor of my own. I don't know if we can make sockets in here. Physics. I don't think there's anything to do in here. Let's just save this, I think. Let's actually, hold on. I'm gonna write this down so I don't forget this. The dimensions of this. So flat 4M. Flat 4M is gonna be 4 by 4 by 25 centimeters high. So that's our basic building block. It has no walls on the edges, and does not change pitch at all. So let's save this. I guess what I could do, what I won't do, is just show it. Usually you'd want to do a subsurface modifier, which is what I was talking about before. That smooths out your, well, it'd be like, let's go with 4. It smooths out your shape, but since it's a square, it tries to smooth it out into a circle, so it cuts the corners off. It makes a nice disc shape. Since we're going for a level editor feel from these blocks, we don't want the subsurface applied, so we're just going to keep it blocky like that, and we're going to put in curves kind of by ourselves. Okay. Trying to think ahead so I don't do too much work for myself. I'm trying to think of, I basically, in Super Monkey Ball, they have flats like this, but with curves on the side. So like a curb on a road where it's just like a little raised portion, so you don't run over the sidewalk or something like that. Basically want to do that for my building blocks, but they're going to be separate building blocks. So I'm going to have a flat building block, and then I'm going to have a curved building block. But I'm trying to think, do I want to make a flat like this and add a curb on the end, like right here? Like it'd be just to kind of show you, it'd be looking like this. Oh, Control Z, just like that. Scale on the Z. That's too much scaling. Scale on the X. Bring that down. Bring that over. Bring that over. Scale on the Y. So, you know, a curved piece could look like that, with just one curved piece. So basically, you know, you could make a piece like this, and then when you go into your into Unreal Editor, you can snap multiple pieces together. Put one there, and then I don't know how to flip things. Whoops. Mirror. Z? Nope. Let's try that again. Why? I don't know what I did. Anyways, you know, it looked like that. I don't know what I'm trying to say. You know, we could build them like that. You know, to make a little runway, basically. But what I'm thinking is, instead of building flats like that, what I'd actually do is build a flat, and then I'd have a separate curved piece. That would be a separate building block that I would have to attach onto the end like that. Be more like that. So that when I attach it to the end point on the end of the flat, I could basically make a line of curbs around wherever I want to. That's my general idea. Okay. So let's just save that. I'm going to try to export this as the FBX format. Okay, that was pretty quick. I was afraid it's going to like crash my computer or something because I'm trying to stream at the same time. Okay, that's our flat 4M. So let's save as, let's do a 2 meter version, a half version, basically. So 2 meters by 2 meters. Done. We can save it. Let's export. No, that's weird. Doesn't pick the saved file name like you used the previous one. So that's our 2 meter. So that's like a little quarter flat. I'm not gonna write that down. Let's do a long and narrow one. Should we? Sure, let's do a 2M by 4M. A 2 by 4. Do I have to do a capital X? Sure, capital X for 2 by 4. So now 4 meters. So that way we can create narrower paths, but along the 4 meter unit mark. Is there a quick way to like get the name? I don't think so. I just wanted to use like the default. which should be the file name. Whatever. 2x4M. So now we have basically 3 building blocks. Untextured. Now I'm trying to think of the texture. Should I UV unwrap them? Now what UV unwrapping, let me just show that off real quick. Get rid of that. I'm going to open up a new pane. And I'm going to change the view to the UV image editor, which is just a flat image right now. No image, actually. No image is opened. So if I go into edit mode, and I select all of the vertices, all the faces, all the edges. I'm going to press U for unwrap, and I can unwrap this, which doesn't look great when you just say unwrap, because it's all one singular mesh without any like edges to cut on, because it doesn't know what to cut on. So if you do a smart UV project, it will basically do cutting of the edges automatically by separating all the faces. The defaults are usually fine, and it created nice 6 nice squares for us, which, you know, because it's a cube, it has 6 sides, but it's not the right shape. Like, let's select this face. That, you know, it's not the same shape. You know, you have a square here, but that's not a square, that's a rectangle, you know, and this is like a narrow rectangle. It is still a square. So UV unwrapping is kind of tricky. So what we could do instead is we could cut this whole thing up. Can I just do this? Mark seam. So now I just marked all the edges. Let me just do something real quick. Remove doubles. There are no doubles. Okay. So now I've marked every edge as a seam. That allows the unwrap tool to basically cut along those seams so that it can do its UV mapping. And I wonder if it's going to do anything different. No, it just makes it more square stuff. Object has non-uniform. Oh, I was doing stuff. I was reading. This is probably what I'm referring to. So object has non-uniform scale. Unwrap will operate in a non-scale version of the mesh. So I don't know what that means. I don't know what's so ununiform about the scale. Yeah, so what? I don't know. I'm sure there's a reason for why it's a non-uniform scale, and the unwrap tool is making it project weird. I think there's a way to view it differently. Oh boy. UVs. Show hide faces. Minimize stretch. I don't know what I'm doing. Stitch seams. I could swear there is a way to change the view of this so that it showed you how much it was stretching by. But I seem to have forgotten. Let me just take a look here. Alright, time to Google this. Oh, we have to, in this view, press N open up this display thing. And right here, stretch. Oh, they're not stretched. I don't know why the scale does not display over here. Weird. Let's say I were to go into paint mode, texture paint mode. Edit the tools, close that, zoom out a little bit. Thank you, Google, for that. That lovely answer. Missing data. I have to add a paint slot. So let's just quickly add a nonsense material. And we have to add a texture, I think. Wait. I'm doing something wrong here, I think. Using nodes. There we go. Image texture. Let's go to here, image texture, and yes, image texture. Am I doing this wrong? There's no like paint texture. I've never done texture painting before. Add a paint slot. Let's just go with diffuse color. Black sounds fine. Black like my soul. That, I'm just kidding. I'm not that goth. Well, painted it all black, didn't it? Oh, it didn't. Okay. It'd be nice to see if we could view it over here. Cancel. There we go. So if we were to undo that, scale this down. If I were to basically draw a circle here, get a circle right here, but you can see that our circle does not really represent the circle here. It's more like a flat, fat, and short circle over here. So the stretching is indeed real, which kind of sucks. You know, I draw a circle over here. I said I draw a circle over here. I don't know why I can't draw a circle. What's going on? I don't know what's going on with this. There we go. I have no idea what's going on over here. Just trying to do an example. Blender. And I can see the circle looks just fine over here. Horrible over here. I have no idea what's going on there. That's why we are definitely not adding materials and textures here in unwrapping, because it's kind of useless. What's up with this? That looks normal. Because I kind of drew it at an angle. I think we can also do painting in here too somehow, I think. I don't know how. Definitely cannot paint there. So that's a problem. But we're just not going to worry about it. So just delete that material. Get rid of that. I mean, it's still there, I think. But we can't delete it for now. I don't know how to delete that. No, don't. I don't know how to delete this. Object. What is this? It's still there. I don't know how to delete it. File. External data. I don't freaking know. Blender. Stack Exchange it is. Delete. Blender. Delete material. This is a learning process. If you want to delete material or texture slots, then you select it and press the minus sign to the red materials. That should remove the material from the object. The actual material data won't actually be gone until you save and reopen the blend file. Oh. So let's make sure we don't have anything selected. Let's just save this off. And we'll just open that again. Did it work? It removed it. Okay, so just refreshed the materials, and since none were linked, it just forgot about them. Cool. Did I export this already? Thumbnails, small assets, models, delete this, MGB level blocks. Yes, I have exported this. Good. Move this window. All right. So I have a 2x2, a 4x4, and a 2x4. Those are basic flats. I think I want to make some curved pieces. Let's do a basic curve, because I'm a basic kind of guy. So we're gonna make this a 4x4. Formula 4 meter. Should I do it this way or should I do it a different way? I could do it a different way. Let's do it a different way. Delete this. I'm gonna make a new primitive. I'm gonna go with circle. And we're actually gonna put that at our origin. So that's our circle. Dimensions 4x4. Is that right? No, I want 8x8, I think. So now our radius is 4 meters. You know, from here to here is 4 meters. I want to basically cut this off at a corner. So a way I could do that is, let's go into our top view mode. Let's go into edit mode, and I will basically use the knife tool. Use the knife tool. Okay, hold on. Use the knife tool. What's going on here? 7. Knife tool. It's not homing in on my thing. I select a face. No, this doesn't have a face. Let's make a face. There we go. So now we have actually a face to it. I think that's why the knife tool wasn't working. There we go. So now the knife tool has a face to cut on. We're just going to take this, connect it from that endpoint to that endpoint, cut, make another cut this way. Good. So now we have 4 separate corners like this. So we'll just select these 3 and delete them. What have I done? Delete the faces. There we go. So now we're just with this corner piece. That looks pretty good. Now I want to, let's go into object mode. There's 2 things I want to do actually. Let's go back to edit mode. Click on this face. And we're actually going to extrude out a bit of material along the Z. And we're actually going to extrude out 25 centimeters. 25 meters? No, 25 centimeters. Because that's our building block height. Now, let's... You know what? Let's look pretty good. Our origin is at this corner. I think that sounds fine. That seems okay, I think. No. No, I don't want it to be there. So let's move our 3D cursor, this little thing, to right there. Specifically, it's going to be 2, 2, and then 0.125. So it's 12.5 centimeters up. That looks good. I think it's Control Shift Alt C. Yeah, origin to 3D cursor. That places our origin point at the 3D cursor. So now if I want to like rotate, it rotates around our origin point instead of on that corner piece. That seems pretty good. Yeah. So now if we were to be building blocks in the Unreal Engine editor, the center point lines up with the exact middle point of this side and the exact middle point of this side, so that our 4x4s will connect right there and right there, so they'll line up. Now, a thing I actually want to look up right now on stream. Right here. Unreal. I want to look up sockets. Setting up and using sockets with static meshes. Because I want to make sockets on the midpoints of our little building blocks. I'm gonna write. Let me write down the size of this corner right now. It's a it's 4x4. 4x4 by 25 centimeters as normal. Just pardon me while I write this down. And with radius of 4. So that basically means that we have a quarter slice of a circle. Okay. It's good to write things down, so in case you do forget them, it's down on paper. but usually writing the thing down will lock that information in your brain. So taking notes is always a good thing, especially handwritten notes. Much better than typing, I found during college. Alright, so I want to learn how to set up and use sockets with static meshes. Let me save as rounded corner. No, it's just gonna be a 4 meter. Yeah, that makes sense. And export that so we have that available to our engine. Okay, that's good. I mean, I don't know if this matters actually. I wonder if I have to set at the origin for well, at 000 world coordinates for the export to work normally. So let's just overwrite that export. Right, back to Firefox. Let me read this then. While making your level in UE4, there may become a time where you want to attach something to your static mesh. You could parent an object to the static mesh in the world outliner, but you still have to position it in the exact place you want it in relation to your mesh, and that can get tedious. However, just like you can attach objects to your skeletal mesh through the use of sockets, you can also attach objects to your static mesh using sockets. It is as easy as creating your socket in the static mesh editor, placing it where you want it to be in relation to your mesh, and then attaching an object, whether it is a light, particle effect, or even another static mesh, to your mesh. This how-to will show you how to create a socket for your static mesh and how you may be able to use it in your level. So, setup. You may already have a level and static meshes of your own to work with. So let me actually bring up the Unreal Editor and we can do this live. So I have a few basic building blocks I can work with. But I will do more off stream. Maybe we'll get some before the end of the stream too. But for now I want to try to do sockets and stuff like that. But I already showed you how I thought the curved pieces might work out. So you'll probably see those in the next stream maybe. Hopefully I have some collection of level designs ready to go for the next stream, and I'll show off a few of those designs, and then we can move over to Unreal and actually construct those levels. That's my idea for the next stream, because our movement is pretty much done. And also during that stream I might, depending on if I'm getting bored with level construction, I might work on creating the level complete gate in Blender, so we can make the static mesh for that, which might have an animation with it too, but I don't know how to import animations over to Unreal yet, so I'm gonna have to do some research on my own so I can get that correct. So we're almost loaded up with a project. Let me go back to the Firefox here. Oh, hello. That was pretty quick. So let me just import that right away then. I am going to make a folder in here. Gonna name Gecko Ball. Move those into there. It does not like that I try to move all of those at once, because one of them is like 100 megabytes. That's my original sphere. I could probably delete that one, but I think I want to keep. I hope it worked. Oh boy, this is gonna take a while. This might take a while. No, it's going okay. Oh, I lost my music, and we're back. I'm just gonna delete this. There we go. So now we have our lessened subsurf models. Rename them, I guess. I cannot rename all at once. Should we go for SM for static mesh? Sure, that sounds dandy. I don't know. It's getting late. Just ignore if I make any weird noises or stupid jokes or anything like that. I didn't get a lot of sleep this morning. I mean, like 6 hours, so it's not great. It's not ideal, but hey, it was some sleep. I think I woke up to a dream, but I forgot what the dream is now. Weird. Anyway, so that's organized now. So let's make a new folder, level blocks. And that's where we'll import our level blocks. That sounds good. We don't need to do that, I guess. No smoothing group, whatever. I don't care about smoothing group. All right. That works. That's our 2x4. There's our 4. Okay. They all seem to import pretty well. You know, that's my basic idea for this. You know, do something like this. There you go, quick level. That's the whole idea of it all. But they didn't line up, and that's what the sockets are for. So let's save all to save those imports. Now I got rid of the asterisk on the icon, if you're wondering what that is. So let's edit this. Okay. There it is. Mesh. Asset. Collision window. I don't know how to set a socket. Let's just reduce these just in case we need to move around. Socket manager. Create socket. Is that right here? We don't need to name these, right? Relative location 400, because this is centimeters. No, 200, because we're offset from the center. There we go. So yeah, the whole width is 400 centimeters. 1, 2, 3, 400 centimeters. But from the center point, it's 200. So that's socket number 1. Tag, I don't know, positive X. What are tags used for? Oh, I know what tags are used for, yeah. So we'll go positive X. Then we can make another one. Socket 0. What kind of naming convention is this? We'll go do -200. Can I talk today? We'll see. Find out at 10. Negative X. Preview static mesh. What is that? We don't need to do that. Well, we could try it out. No, we don't have sockets for the other ones. Do they need sockets? 4M. Rounded corner. Oh. Okay. Just figuring this out as I go. Another socket. And this will be 200. This is a positive Y. New socket. -200. This will be the -200. No, -200, -Y. And I will do sockets for the Z's as well. So 25, that'll be the very top. That's not right. Again, from the center, plus 12.5. That's positive Z. Last socket, -12.5, negative Z. So there's 6 sockets. Save that off. Let's open up this rounded corner because that one is the most interesting. And we will do similar sockets. This socket will be -200 on the X. There we go. Negative X. Another socket. 200 on the Y. This will be plus Y. And I guess I can do the Z's as well for this one. 12.5 plus Z. Is that right? That looks right. -12.5, negative Z. So we'll save that. We can't do positive X or negative Y because there is no mesh there. So it makes no sense to do it there. Now what does it look like? Let's preview the forum now. Huh. Socket created at import. No. So we'll have to see how that looks. Let's go to Firefox. Creating our first socket, we know how to do that. Socket manager, create the socket. There's that button in there, right? Yeah, that's cool. Good to know because it was getting a little crowded in here. Where am I? Firefox. How do we do this again? Now that we have a socket in our static mesh to attach, we are going to attach an object to our static mesh in our level. Click the save button, find your SM door frame. So I did do a pretty good nomenclature for that prefix. Good to know. Inside your content browser, after you've done that, go to the... Oh, excuse me. I have to crack my neck. I was getting stiff. After you have done that, go to the particles folder. Find the asset named pfire. And then they do attach to. So let's scroll this back a little bit. So let's go over here actually. No, let's go over here. I made up my mind. Okay. So if we make a 4 meter here, I cannot see that now. 0Z. So for now, we're just gonna kind of guesstimate where this lines up. It's a little bit over. Move it down a little bit. Sure, that's fine. That looks fine. Yeah. And now that's static. That's good. So I might want to name this. Where's the rename? Can I just press F2? Okay, this will be the level block test. Now if I go drag onto here, can I just drag this onto here? Attach to socket. Oh, they don't have the socket names in here. That'll have to be changed. This is very literal in its position. I'm wondering if we can attach sockets to sockets, basically. Unreal sock to socket. I have a skeletal mesh with a number of bones. Socket A, I need to attach socket A to a socket B. Set the origin. So we're going to have to offset these basically. Shoot. It kind of sucks. Yeah. Crap. That's not great. And we have to rename these sockets too. The tags just aren't good enough. I think that's used in programming. These socket names are used for the GUI. So this is going to be plus X. Plus X. Oh my god. It's only 9:47. I shouldn't be this tired. See, we're basically going to have to double every. What am I doing? Minus C. Double every value. So that when I place my rounded rectangle here, since it has a radius of 4, well, I mean, it's a 4x4, but its origin is at, I guess 2x2, if you think about it. So if I preview the rounded corner here, it fits on there just fine. Okay. Just a little minor setback. Not as elegant as I would have hoped, but I guess we can't help it any much or at all. I don't know what I'm trying to say. Maybe I should say less when I'm streaming. Maybe less is more in this case. So now they're offset. If I wanted to stack, you know, flats on flats, I could do that. So if I need to make like a elevated tower or something like that, I could just, you know, do a bunch of flats and they'll line up perfectly-ish. All right. Cool. Save that. Do the same for here. At least we now know that the names over here will not show up in the editor. Or they will show up in the editor. The tags will not. So we need to make sure we edit both the tags and the socket names. Good thing I didn't have like 20 level blocks, and I just found out that they needed to be changed. I'm doing this pretty early in the building process. Not much of a setback. That's good. So now if I basically delete this, put that back in there. We'll put it at 0. Down a little bit. And move forward this way. Seems just great. Now if I, you know, put a rounded corner in here. I don't know why I can't just put a rounded corner in there. Can I add a component? If you go static mesh. Oh, it's usually when I'm selected, right? Yeah. Or can I just drag it into here? It didn't do it very smartly. What I wanted to do is do this, attach it, and now it does it. So let's do positive X. That's that. Let's see if building the lighting will remove that line. That's my guess. Excuse me. I hope you're enjoying the music. This is the Nintendo Philharmonic Orchestra performing the Super Smash Bros. Melee songs. Well, some of the songs from the soundtrack. So you have a nice mix of songs. I was building this is what's on the track list. Planet Corneria, Jungle Garden, Great Bay Shrine, Dr. Mario, Original Melody, Fountain of Dreams, Kirby, Pokemon Melody, Opening, Planet Venom, Yoshi's Story, Depth of Brinstar, Smash Brothers Great Medley, Fire Emblem, Green Greens, and Rainbow Cruise. So it gives you a nice variety of Nintendo songs. And it's live Philharmonics. So I got the CD back when Nintendo Power was still around. Oh god, it's so dark. Why is it so dark? I'm gonna search for something. certain something. Light mass importance volume. Not quite sure what these do, but I've heard they're important. So that's right there. And let's scale this up. We can actually do this sweet orthographic view where we do some of this. Where the heck is my view though? Oh, it's like zoomed in, mega zoomed in. So now we have a little view of everything. So now I can try to encapsulate everything in my level by looking at certain values. Not Y. X I want to increase so I can get that little ramp in there too. I'm not quite sure what the light mass importance volume does, but I know that it is important to light and it encompasses a volume or a 3D space. I wonder what that does. And I know when I've built a lighting before, I think in this, it said, warning, no light mass thing available or something like that. Do I have the developer tools output log? Warning. I don't think it's in here. No. I don't think it warned me about that. Cool. So if I build lighting quality preview, build lighting only, what does that look like? I might have to give this some material just so it shows up properly with lighting. That might be it. I want to make sure I get this right though. I don't want to have building blocks that can't be lit properly. Neat stuff though. I'm trying to think of the levels I can build. These building blocks can be pretty useful for a generic building. But I think I want to, well, I would definitely, for the rounded corners, I would need to make several different sizes. I can make like intervals of 2, so I can make a 2-meter version. I have the 4-meter version already. I could go 6 meters, 8 meters, so on and so forth. So I can have different radii. So that didn't do it, by the way, for lighting. Because I want to have, what do I want to have? Oh, different curves, you know. This is a fairly tight curve here. But I was thinking about doing, like in the first level, a big circular area or something like that. Or maybe like a bowl like I've done over at target point. Let's see. This one. F. This bowl I've done. Kind of like a similar idea like this. And the goal is kind of in the center here. So that you fall into the hole. Basically. But I can't really do something like that with building blocks. Sort of. Unless it turns out a lot of my level designs have big round inverted domes or bowls, to put it lightly, then I might make level blocks like that. But I also am thinking even more towards the future, where I think I want to build a level editor for the players so that they can basically use the same building blocks I have, apply certain themes to their level, so that the materials can be selected and everything like that. That way people can make their own levels in this game. I think that'd be cool. I think that's part of the why I wanted to do level building blocks like this anyways. So what if I just apply material to this? Materials. That's not what I wanted. Basic floor. No, let's get something with more color. Marble. Gotta wait for it to load, I think. But what else is there? There's slate, shelf, however that is. There's some of the materials for textures, or not textures, emitters like the spark. Wait, did it do it? It made it shiny. I don't understand what it's doing. It just made it shiny. Let's go for pine. That'll be distinctive enough to see if materials are even working at all. I hope the fact that you can see shaders compiling. The fact that I did not unwrap the models, the static meshes, that is being confused and it can map the textures, I think. I hope that's not what's happening, because then I have to do that for every single static mesh. I mean, I could do the smart automatic UV mapping, which would be fine, but I wouldn't want to have to do that. Is there anything we can do in here? UV. Uh-huh. So it does have some sort of UV channel on there. It just doesn't show me anything useful. Show. No, it doesn't show me anything useful here. Okay. The shaders are done compiling, and now it is nothing. It's a color. I think I'm going to have to unwrap this stuff. Alright, let's do it. Let's do it real quickly. Warning. Warning. My computer may crash. The stream may go down. Last time I was trying to do Unreal and Blender yesterday, it was not very happy. That was with dealing with like 8 million vertices on a single static mesh kind of issue. NT. Open this up. Edit mode. All. Wait. UV image editor. All. Not unwrapped. Do smart UV project, because that's the best we can do. I think. I don't know if I'm doing something wrong here. It feels like I'm doing something wrong because they're not the right shape. Maybe it's because I have subsurface divide on. Or not subsurface divide on. Like, what if I did 0? Subdivide UVs. Smart UV. That did nothing. But I'm sure if I did something like this, I did smart UV. Oh, no, it wouldn't change because it's still the same shape. It's just how it looks, nothing like how it is actually behaving in UV mode. So never mind that. Edge split. Decimate. What is it? These are great explanations of what's going on here. I could try to do a triangulation. It doesn't really show me a preview at all. What does it look like? Well, fine. Okay, what did that look like? No, nothing. Alright, let me just Control Z that. Control Z. I think we're at normal. I don't. Okay, whatever. Is that the best we can do then? Mesh deform? I don't know what I just did. I clicked on some things, some stuff happened, and it resulted in nothing different. Remesh? There we go. Oh, it did something over here. Oh my gosh. Okay, we're back to normal. I mean, maybe remesh might work. There was a remesh. Octree depth. No. Mode. Smooth? No, please don't do that. No, let's do blocks. What's going on here? Sharp. Apply. So vertices 8, edges 6, or faces 6. It seems to be the same shape, but I've remeshed it. What if we do a smart UV project here? No, it's still squares. I don't get it. I don't get it. Why does it not scale it? Google, please help. Blender, UV scale. What was it? Non-uniform scale I was complaining about. Yeah, object has non-uniform scale. Unwrap is because your object has been scaled on some axes more than others in object mode. Yes, it should be fine, but if you're having problems, you can try applying the scale by pressing Control A, scale in object mode. Oh. Apply the scale. Now our scale is 111. Even though the dimensions are changed. Oh, this sounds good. We've done it. We've done it. I mean, not me. Google did it. let's give a shout out to this guy. Gandalf 3, 105 updates, whatever they're called. Dude, this guy's the bomb. Can I update it? No, I can't. I have to log in. That's awesome. And can you believe that? Like, maybe applying the scale would be in a menu, you might think. Maybe there's a place to apply the scale. Like maybe that, but no, that's different. I think that's different. We don't need this. The scale doesn't really do anything, does it? I mean, it does do the scale. What if we like go into that scale on the... No? What are you doing? Scale? On the X? I don't know what's going on. It's scaling very small. Anyways. I don't think there'd be an apply scale option there. You have to press Control A to apply. Look at all these options that they have in menus, you know? Snap. There's so many options that are just hidden and you don't know where they are. It's a bit ridiculous. But I think we have done it. We've unwrapped successfully. That was a chore and a half. Export to FBX. Export. Hop over to Unity. I always call it Unity. It's Unreal. And let's import. Let's see if we can just overwrite it. Yes. Good. Oh, the socket information is still there. Is that right? Save all. Oh, it looks wonderful. The socket information is still here. That's great. Okay, so I can overwrite it, and now the UV. Oh, what is this? This is awesome. This is obviously for double-sided texturing, I think. I don't know why I say obviously all the time, or of course it's going to be like, why do I say that? This is weird. It has like a slightly smaller scale. I don't know what that is. Point is, successfully UV unwrapped, it now appears with wonderful one-to-one texture mapping. That is wonderful. But it does not apply that material to subsequent. I cannot talk. Subsequent. I'm thinking about the word and that sounds wrong. I don't know why that sounds wrong. Anyways. We can work with this at least. Okay. Let's mess with, first of all, let's mess with just building stuff. Plus Y. Kind of wish I didn't build the stuff in here. Anyways. I wish this was faster. So that's the X. Attach it to the X. Can you believe this is what's going to happen? But we need to because it's socket to socket to socket. Let's look at the seam. They pretty much match up properly. There might be some overlapping a little bit, but that'll be fine. Positive X. Let's add another one. I wish it kind of snapped to like sockets in the editor instead of having to go into the menu to do it, but and I hate that you can't attach it straight away. Can I do that? No, because then it just puts it in there. That's not what I want. Control Y, video attach. So put it in the level first, then attach it. Plus X, rounded corner, plus X. I admit that's gonna look absolutely ridiculous when I have like a full level in here and it's got like 60 components on it. That's just gonna be ridiculous. But hey, it's gonna work. I swear it's gonna work. Can I convert this to something? Another way I could do it, I think, is to just do grid snapping. Do like 100. Can I do a custom? I don't think I can. So I could like snap to there or something. You add another one in there. I could do, you know, just snapping like this. I could also do that. Something. Oh God, I pressed something. I don't know how that worked. I don't know. I pressed a button. Of course I pressed a button. No, I pressed a... Oh, I went to Shift 2. That's what that was. My mouse has buttons on it that map to 1 and 2. How do I get out of wireframe mode now? Alt to 2. I press Shift Alt. How do I get out of wireframe? Alt 4? What? Why is 4 or lit at 4 and not like 1? Anyways, it's a whole jumble of messes. So I could do that. That doesn't sound fun though, if I'm gonna be honest. Plus with this, if I just select on this, look what I can do. Yeah. Anyways. Can I attach from here? That'd be great if I could attach. I don't think I can though. Level of detail. Yeah, put one in there. Oh, pressing wrong buttons. Attach. I don't know. It's just easier to do it this way. Plus Y. Rounded corner. Plus Y. How do I deal with this? I guess I'd like maybe do something like this when I'm in edit mode. View options. There's no great display icons are currently selected. There's no great way to excuse me, to condense this view down. Plus now we have to rotate this bugger. Wait. No, wait, what? Why is the origin right there? No, that's not right. Wait. What's going on here? What the heck? Rounded corner. Place that on that guy. Positive Y. Okay, there was some weird stuff going on there. I don't know what was going on there. I mean, this is at least my idea is working. Let's remove this. 5. But it's, yeah, again, not elegant. Oh, and then it flips because I had to rotate it. Now the negative X is there. That's not confusing. This is definitely not elegant. Yep. Oh well. Oh well. I guess I could do something like this. Yeah, I'll probably make it into like separate parts where I have like, if I do like one straightaway, I'll break that out into one component like this, like that, and then I'll attach it to like a turn. I'll do the turn, I'll connect the turn to that socket, stuff like that. So basically be like a tree of connections rather than a list. But let's finish this one up. This little test area, -X, rotate. Again, it's doing the weird rotation. Control Y. We have to click on the thing again. And then now it has a proper rotation. I don't know. The snapping stuff is not flawless. Now who knows? Nope, not positive Y. I don't know how to change socket point. What if we go like this again? Nope. X. There we go. Not great. -X, which is not X. It's relative to that, which to this, that, I was gonna say the red arrow. What the freak? I have to change the local, I think. Yeah, local coordinates that way is X. This is -X. So it's a little confusing, but I think it could work out. So we connect that to -X. I guess that works. I don't know what this little, oops. I don't know what that little icon means. There's like a star and then it has like a funnel shape. I don't know if there's like different types of sockets then, because they say socket or bone. Anyways. So attach that to -X. So that's our little test level blocks. What if I go to this top one and I say put another rounded corner in there. Well, again, reduce that, attach that to the positive Y. Click on that again. You'll rotate it 180 degrees. Now we have that. Interesting. Interesting. All right, let's see what that looks like. Lighting needs to be rebuilt. Oh. The physics on the collisions are a little bit wonky. Huh. This is gonna require some fiddling, I think. All right. Holy cow is one way to put it. Holy cow is one way to put it. Well, that's something and a half. But I think that does it for today's stream of Mega Gecko Ball development. Title work in progress again. Gotta throw that disclaimer out there. So off stream, I have a list of things I need to do. I need to fix the unwrapping all of my existing meshes. I will need to create more level blocks, and I will need to make curbs for my level blocks. Yeah, I gotta think. Excuse me. Is there a way I can convert this combination of meshes into one giant collision? I mean, it says character can step up on. Is that? I wonder if like that might be doing some weird things. So if I'd like to change a few of these to owner. Well, can I select multiple of these? Say owner. Well, let's just use this. Owner. Let's play with that just before we exit this. No, it's still wonky physics. All right. So I'll off stream, fix the UV unwrapping so we can get textures on these buggers. Tweak the at least see if I can tweak with the physics at all, or the collision on this. Man, it'd be nice if I could make like a I don't know. What am I trying to say? If in like Blender, I guess. If I can, well, I could, if I wanted to, I could, I could use like the grid to line things up and snap along the grid. You know, selection to grid, so I can, if I wanted to, I could make like a, that'd be cool if I could open other objects as primitives, basically, like this, other meshes as primitives. But I don't know if I can. So I can maybe make my levels in Blender, so that the static mesh will have a single collision mesh for the whole level built, instead of in here where we have a collision mesh for each one, and at the seams their collision meshes are overlapping, so that creates problems. And I don't know where this collision primitive comes from. I don't know where that comes from. Oh, it auto generates collision. I'll have to figure out how to like make a collision mesh or something like that, or use this mesh as the collision mesh if I can. Yeah, I'll figure that stuff off stream, so I'm not boring you guys anymore. Yeah. All right. A lot of nitty-gritty details in here. But so today was, I think, a pretty good success for what we were focusing on. Our camera now works pretty well. We have limits on our view, but we can orbit around the character, and we now move forward in the direction the camera is pointing. Yeah, and I showed off my debug teleporting abilities. I've shown off my nice slowdown to automatically stop our character once we hit a certain velocity, so we can come to a rest. And we've made a few building blocks for levels, so we can start implementing level designs once I figure this collision problem out. So hopefully I can do that off stream. If not, if it does become more of a problem than I think it is, then I might stream me solving that, at least, since other people might run into a problem like that. So thank you for coming out tonight. I know today was maybe a little bit dry, a lot of technical things in here, and some things that didn't work out too well. But you know, it's all part of the process. We'll get through it. I think we'll get through it. With your help, I can do it. So, thanks. I'll see you next time, guys. All right. Bye.